we are going to do a sentimental analysis over the Twitter data. So this we are going to do through deep learning method. So we'll use neural networks to train the model. So first, and I'm going to implement this one into the Google Colab. So here we are importing the important libraries. So I have imported pandas, NumPy, regular expression string, NLTK, Kera. So Kera is the important library for the deep learning here. So I have taken the tokenizer from the pre-processing text and model selection. I have taken if from scikit-learn to split the train and test data. And from Keras we have taken the activation, dropout and dense layers, and the models we have taken as a sequential. So from here we can read the data. So we got it into the data frame. So this is the initial check, like how correct data we have. We have a three columns: ID, label and tweet. So we are going to reprocess the tweet before going to feed that one into the model. So we have 29,720 records for the level 0, and for the 1 we have 2,242. So 0 is the positive sentiments and 1 is the negative sentiments. So this is like one of the view, like this is the view of the fifth row, and this is the distribution of the positive sentiments and the negative sentiments tweets. So of course we have a lot of positive sentiments tweet, and negative one is we have a lesser value. So we can delete the ID, column ID here. So after deleting, this is the view of the dataset, and we have defined a function here which will reprocess the data before we'll feed it to for the tokenizer. So here we are sending each tweet to this function where it will remove the URL, it will remove the hash tags, and it will remove the @ and punctuation, everything. I have given it a little bit more in detail here. So we got the clean data into the X list. So we have stored that one into the list. So like before processing this was our input tweet, and after processing this is our final tweet. And we have also removed the stop words from this tweet. And why, like in the why we have taken all our classifiers like 0 and 1, and here we are splitting the data x and y into the training and test based on the test size of 40. So the 40% of the data will be for testing and 60% data will be for the training. And this is like the just a print statement, like how many number of training samples we have and how many number of testing samples we have. And we have a two classification for sentiments like 0 and 1. Okay, so here is the main thing where we are going to implement our for the model. So for the model, the input should be in the matrix way. So we have defined the vocab size like 5,000 and tokenizer, and we have given the num words as a vocab size here, and we are changing the x train to the tokenizer, and it will change like from text to matrix. So basically we'll get the value here in the binary mode like 0 and 1. So how many so in one record it will display how many which word is coming as a 1, and the word which is not coming into that tweet, it will be labeled as a 0. And here we are just converting y into the categorical value. If you see it here, so we have 5,000, like the 5,000 column for the 5,000 words, and we have 19,177, like that is the count for our training x. So this is the basically the word index which has been created due to this tokenizer, and this normally what it does, like for each word we have a word will be the key, and there will be value that will be a numerical value that will be assigned to that word. So this is how, like, basically we don't directly fit the text to the model. We convert it into the numerical value, and then we put it into the model to train it. So here, after changing it to from text to numerical, we have done a binary modeling. So it will summarize into the matrix. So whatever the value is coming to into a particular tweet, it will be whatever the words is coming into the particular tweet, it will be labeled as a 1, and rest word will be as a 0. So that's why we are getting the shape as, like, we have a 19,177 row and 5,000 columns. So here I am defining a model in which I have taken the max word as a 5,000. So model is basic model is a sequential in which I have added the dense, and input shape I have given it as a max word here, which is the 5,000. Then I have added a activation, which is nothing but RLU type, and then I'm adding a dropout layer here with the 0 0.5, so half will be dropped out, and then I'm adding again one dense layer, and then I'm adding an activation with the softmax. So softmax is like it will give our output in probability way, like it will divide with summation of all the value. And so okay, so after defining it, like we have to compile the build, compile and building the model. So here we'll compile the model, and this statement will give all the model summary, like what is the input, what is the parameter we have passed, and how many layers we have. So now here we are going to do the training the model. So in which here what we are doing, we have a batch size of 32, epochs is 10, and I am fitting this one with xtrain and ytrain. Batch size is like I've given 32 here, epochs is 10, verbose is 1, and validation split we have done it for the 0.1. And in the score we are evaluating x test and y test with the same batch size, and at the end we'll print the loss and accuracy. So here if you'll see, in the first epoch we got the loss of 18%, and accuracy is 94%, and again the loss is getting decreased and accuracy is increasing. So this is for the training, and this is the wall accuracy, like this one is for validation accuracy. So this one is 95.62, then 95.88, then 95.57, 95.72. This is the last epoch. So after that it will display the test loss and test accuracy. Okay, so we have a test loss of 26%, 26.74, and test accuracy we have 95.64. So here, like we have already defined the history here, so this will give all the keys. So we have loss accuracy, val loss, and while accuracy. This is useful to draw the plot to summarize like how it has been come up. So this is our plot basically. Like this is the training data, the blue one, yellow one is the validation data. So this is for the accuracy. Like after each epoch, our accuracy has been increased, and there is very slightly variation into the validation data. And this is the model loss. Like we have a training. In the training, we are increasing the loss, which is good, and the validation at the starting it was fine, but it was increasing as we going ahead with the epoch. So this is the model which we have created for our basic data, doing the data analysis through deep learning. Thank you.